So let's look at number 6. So if we want to use this using substitution, well, the inside of the cotangent function is 4x. So I'm going to start off by letting that be my u. So we'll let that be 4x. So then du is 4 dx. I don't actually have the extra 4, but I've got my dx, so I can solve this for what I have, which is dx. And so now when I see dx in the integral, I'm going to replace it with this. So this integral, I'm going to pull that 5 out front, becomes 5/4 times cotangent of u du. Well, now the problem is cotangent of u is not a known derivative of any other trig function. However, I can rewrite cotangent as cosine of u over sine of u. So this one's actually going to require a double substitution. So I know that cosine and cosine are the derivatives of each other, and so if you have to make a choice here, you always want the denominator to be the thing you substitute because you need the derivative to be on top. So now what I'm going to do is I'm going to substitute again. I'm going to pick a new letter. So let's let v be the sine of u, and then dv is cosine of u du. So now I'm going to do a second substitution. So first I change it from variable x to variable u, and now I'm changing it again into variable v. So if I rewrite my integral with my new substitution, I get 1 over v dv. Well, this is something I can anti-differentiate. It's 5/4 natural log of the absolute value of v plus c. Now I need to put back in what v was standing for, and v was the sine of u plus c. And now since I double substituted, I've got to double substitute back at the end. So now the final answer is 5/4 natural log of the absolute value of sine of u, and u was 4x. So this is my final answer. Number 7. Well, this one's a little bit tricky. So notice the log base 3x is in the numerator, but we have a 7x in the denominator. And so generally we would use the denominator as our u because it's hard to undo that otherwise. But we actually know that the derivatives of logs involve x's in the denominator. So I'm going to let my u be the stuff under the radical. This is going to be log base 3 of x, and the derivative of that is 1 over x natural log of 3 dx. So the only thing that I have in my integran is I've got the x in the denominator and the dx on top. So that means if I replace natural log of 3 du in place of 1 over x dx, I'll have all the elements I need. So I'm going to pull the 1/7 out front before I make my substitution. So now, when I make my substitution, I've got 1/7. My u is log base 3 of x, so this is going to be u to the 1/4. And then my 1 over x dx, right here, gets replaced with natural log of 3 du. So natural log of 3 is a constant, so I'm going to pull it out front just to get my constants out of the way before I anti-differentiate this. And so this is just going to be a power rule. So the constant stays out front, This is u to the 5/4 divided by 5/4, which is the same thing as multiplying by 4/5. And now I've got to get it back in terms of x. So I'm going to bring all my constants out front. So I have 4 natural log of 3 divided by 35 times the 4th root of log base 3 of x to the 5th. I could have also written it as log base 3 of x to the 5/4. I just wanted to put it back in the same form we started with.